okay? So we've created effectively a film of biology on our planet. And this film of biology is highly interconnected. Viruses have the potential to jump into animals, to move from place to place. This part of the world, you've all experienced avian influenza and poultry populations very recently. As a country, we've experienced big loss to the porcine epidemic diarrheal virus. This is a pig virus that probably started in China. And of course, all of us are familiar with the diversity of viruses that have an impact on human populations. And this interconnectivity, really changes the nature of our risk and puts us in a particularly exquisite kind of risk. And these risks are intense. And examples of these risks, of course, include Ebola, they include HIV, they include SARS and MERS and constant influenza that we experience as a human population. But it's not just the natural risks. At the same time, there's the potential for purposeful and accidental risks. There's the possibility of bioterror. These are situations that we have truly experienced in the past of terror organizations like Aum Shinrikyo that attempted, fortunately not very successfully, to take anthrax and basically eject it off of the top of a high-rise building in Tokyo. And interestingly, this was an outbreak that didn't really cause much damage to humans, fortunately, but the way that we identified this was it actually harmed some cats and dogs, some pets, so it brought it to people's attention. And then we also have the potential for accidental spread of infectious diseases. And you may think that the accidental introduction of new microbes into the human population would be something that would be quite rare, unimportant, but there are certainly some important, notable examples of this happening. In fact, a major influenza outbreak occurred in the 70s, and one of the things that was very interesting about it is we took a look at the sequence of the virus that caused that global outbreak, and we looked back, and what we know about flu is it's a very rapidly evolving virus, so it's constantly changing itself over time. But this virus was almost identical to a virus that had been present in the 1950s and hadn't changed at all. And that's something, the only way that we could explain that change, the lack of change there, was in fact that for the last 10, 15 years or so, that virus had been sitting in a freezer. And that at the time, there was another small outbreak that occurred, and it's almost certainly the case that this particular influenza virus emerged from a laboratory when somebody went in to do additional work on influenza associated with a small outbreak and then spread throughout the world. So we really have an exquisite set of risks associated with these phenomena, and something that we've never really faced as a human population before.